Today in geometry, we are looking at the last lesson before our test. So we're looking at law of sines and law of cosines. We can use the law of sines and the law of cosines to find sine lengths and angle measures in acute and obtuse triangles. So we were using SOHCAHTOA in right triangles. So today we're going to look at, if they are not right triangles, how can we find the missing side length or a missing angle? The law of sines states for any triangle ABC with side lengths A, B, and C, opposite angles A, B, and C respectively, the law of sines relates the sine of each angle to the length of the opposite side. So in this triangle, if I have ABC, if this is angle A up at the top, then this is side A. Angle B across from angle B is side B. Angle C across from angle C is side C. The law of sines says the sine of A over side A is equal to the sine of B over side B, which is also equal to the sine of C over side C. The law of cosines, again in triangle ABC, relates the cosine of each angle to the side lengths of the triangle. So again, we'll label our side lengths, opposites of the angles. We have three different law of cosines. The first one says a squared equals b squared plus c squared minus 2 times bc times the cosine of angle A. And then we have b squared equals a squared plus c squared minus 2 times ac cosine of b. And finally, c squared is equal to a squared plus b squared minus 2ab cosine of c. Remember, the lowercase a, b, and c's refer to side lengths. All right, so first you must determine what information you have and what you need to find in order to know which law we're going to use. So this just says solve using the law of sines or cosines. So over here, I'm just going to list what do we have. Okay, we have two angles in one side. We need, so it says for triangle XYZ, what is YZ? So this is my X, okay, to the nearest tenth. So I need a side. I have two angles and a side, and I need to find a side. So this would be law of sines, LOS. Okay. So my law of sines, I'm going to take this angle and this side. So the sine of 51 degrees over that side length, which is X, is equal to this angle, so sine of 77, over that side length, which is 7. We have a proportion. We know that to solve a proportion, we simply cross multiply. So I get x times the sine of 77 equals the sine, or sorry, 7 times the sine of 51. I'm trying to get x by itself, so divide everything by the sine of 77. So I get x is approximately, because it says to the nearest tenth. So in our calculators, we would put 7 times the sine of 51, and then divide that by the sine of 77, and we get approximately 5.6. We want to answer the question. They asked YZ, so I would say YZ is approximately 5.6. They did not give me units, so I don't have to put inches or anything like that. All right, next one, number 2. Here it wants what is BC to the nearest tenth. So this is what I'm looking for. So what do I have? I have two sides and one angle. What do I need? I need one side. So on this one, if I only have one angle and I'm not trying to find an angle, then I cannot use law of sines. So this is going to be law of cosines. Okay? So the side that I'm looking for is across from this angle. So this is like my A that I'm looking for. So let's say x squared equals my other two sides squared. So 8 squared plus 10 squared minus 2 times both of those sides, 8 and 10, times the cosine of my angle 57. So then I'm just going to start working this out. So x squared equals, so 8 squared is 64. 10 squared is 100, minus, I'm going to multiply 2 times 8 times 10 and get 160 times the cosine of 57. I'm going to add 64 and 100 together, so I get x squared equals 164 minus 160 cosine of 57. So now I just want to type this in my calculator. 164 minus the 160 times the cosine of 57, and I get x squared is equal to 76.8577544. That's x squared. I don't want x squared, so I take the square root of both sides, and I get x is approximately 8.8. But again, I want to answer the question. The question said BC, so I would say BC is approximately 8.8. So we'll look at the back. Number 3, what is G to H? So again, this is my X. I have two sides and only one angle, and I'm looking for the missing side. So again, this is law of cosines. This is LOC, law of cosines. The side that I'm looking for is across from the angle that I have. So again, I would set this up. X squared equals 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 110. And we're going to start working this out. So 12 squared is 144. 18 squared is 324. 2 times 12 times 18 is 432 times the cosine of 110. If I add 144 and 324 together, I get 468 minus 432 times the cosine of 110. Plug all of that in my calculator, and I get x squared is equal to 615.7527019. Again, I don't want x squared, so I'm going to take the square root of that. And I get x is approximately 24.8. So now I need to answer the question. The question was GH. So GH is approximately 24.8. Okay, so number 4, find the measure of angle S. So this is what I'm looking for now, my angle. I have one angle and two sides. I'm looking for another angle. Okay, if I have two angles in my problem, I have to use the law of sines. So this is LOS, law of sines. So I would say the sine of 74 over, so that goes with 12.3, equals the sine of x, that's the angle I'm looking for, over 12.7. Cross multiply, so 12.3 sine x equals 12.7 sine 74. Divide both sides by 12.3. So now I have the sine of x equals, I'm going to plug all of this in my calculator. So 12.7 times the sine of 74, that whole thing divided by 12.3, and I get 0.992522238.9. But I don't want the sine, I want to find out what x is. So remember, this is where I do the inverse. So I would say that x is equal to sine inverse of that 0.992. Type that in my calculator. So sine inverse gets me, and we're going to round to the nearest tenth, so that's going to round us up to 83 degrees. So now to answer the question, the measure of angle S is equal to 83 degrees. Okay. We can also use law of sines and law of cosines in word problems, so that's what we're going to look at next. So number 5, it tells me the map shows the path the pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is this route than the direct route to Chicago? Okay. So I know that the direct route is 471 miles. They give me this angle and this angle. So first I need to find this side. I'm going to call it X. And then I need to find this side. I'm going to call it Y. Since I have my angles, okay, and I'm looking for side lengths, I'm going to use the law of sines here. So I would first say the sine of 113 over 471 is equal to the sine, it doesn't matter which one I find first, x or y, I'm going to do x, so x goes with 22 over x. Cross multiply, x times the sine of 113 equals 471 times the sine of 22. Get x by itself, so divide by the sine of 113. So x is equal to, so I'm typing in my calculator, 471 times the sine of 22 divided by the sine of 113, and I get approximately 191.7 miles. So this is from Omaha to my turning point. So now I need to find from the turning point to Chicago. So again, I'm still going to use the law of sines. So the sine of 113 over 471 equals, this time I'm going to use this angle up here. So the sine, I need to find that angle, but I know that all three angles add up to equal 180. So 180 minus 113 minus 22 gets me 45 degrees. So the sine of 45 over y. Cross multiply y times the sine of 113 equals 471 times the sine of 45. Divide by the sine of 113. And I get that y is approximately 361.8 miles. So this is from the turning point to Chicago. So now I want to add those two together, right? And subtract it from the 471 because this is how much longer. So I'm going to do 471 minus 191.7 minus 361.8. And then when we work all of that out, we get that this is approximately 82.5 miles longer. So to go around the thunderstorm, they had to fly approximately 82.5 miles further than they would have taken the direct route. Our last one. The optimal tilt for Avery's solar panel is between 58 degrees and 60 degrees to the horizontal. Has Avery placed her solar panel at an optimal angle? So the tilt for the solar panel, okay, so that would be this angle down here that we're looking for, angle P. We want to see, is that between 58 and 60 degrees? To have all three sides, I need to find an angle. Okay, so this is going to be law of cosines. So I always start out with the angle that I'm using. That side goes on a side by itself, so we would set this up 19 squared is equal to 18 squared plus 20 squared minus 2 times 18 times 20 times the cosine of P. So now let's start working this out. So 19 squared gets me 361. 18 squared is 324. 20 squared is 400. 2 times 18 times 20 is 720 times the cosine of P. So 361 equals, so I'm going to add 324 and 400 and get 724 minus 720 cosine of P. I'm trying to get the P all by itself. So first I'm going to subtract 724 from both sides. So 361 minus 724 gets me negative 363 equals negative 720 cosine of P. I need to divide by negative 720. So negative 363 divided by negative 720 gets me like 0.504166667 equals the cosine of P. I don't want the cosine, I just want P, so this is where to move the cosine to the other side is the inverse. So I type in my calculator, so the measure of angle P would be approximately, so the cosine inverse of 0.504166667 is approximately 59.7 degrees. Okay. So we look at the problem, and it said that the optimal tilt is between 58 and 60. Is our answer between 58 and 60? Yes, 59.7 is between there. So yes, it is placed at an optimal angle. Okay. All right, so that is our law of sines, law of cosines. Your homework is a law of sine, law of cosine worksheet. Same type of thing that we just did here in the notes. Then also test review. So this was the last section that we have to look at. So tomorrow we will answer test review questions and then the next day take our test.